Alright, welcome to another Advent of Code day. And I thought that, well, today, since I already have OCaml installed for like a couple of days, let's try to use it and then we'll go from there. And I know I said that, oh, I don't like the matrix problems because they have like 2D arrays and stuff. This one actually isn't really that much of a 2D problem. So you'll see what it is about in a second. So let's go through the part one description. So it's called Resonant Collinearity, and I mean the name is kind of what's the problem about. So yeah, first it's like some filler about the Easter Bunny trying to do some shenanigans. So the problem that we have to solve is that we have some huge antennas and they emit some frequencies that make people buy some other kind of brand of chocolate instead of our brand. So, PR isn't really happy with that, so we have to do the unthinkable and get rid of the Easter Bunny basically. So yeah, let's see how we how we are gonna do that. So we are looking at these antennas, right? And we figure out that each one has a frequency, and the frequency is a lowercase letter, uppercase, or digit. And we map the positions. So think about it like, okay, in the end, we just want to get an array that is going to contain, it's not a tuple, it's a tuple, I guess you can call it. It's a 3-item tuple where we have the X, Y, and the letter for the frequency. So it's not really I mean, it's a 2D problem, but we can just create like a hash map or an array of positions. So that's pretty nice. And these antennas create some specific antinodes, right? And these antinodes are basically like the explanation is I had to read it like 5 times to understand it. And it could have been much simpler if they said just that, okay, you have A, it's two of them, and on each side of these two antennas you get the antinode. So if you have A, and the distance between them is 1, you count one more and you get the antinode, and the same on the other side. So it's basically they're on the same line and at the same distance. So that's how we are gonna calculate where these antinodes are. And I guess the reason why this is complicated to understand is just to make the problem a bit harder, because if you think about it, this is really simple, right? We have two positions and we just have to extrapolate the two extra positions that we have to find. Right? And here it shows that once you add an extra node, it becomes like the antinodes multiply really quickly. So I think it's like is it combinations? So if we have two of them, there's only two. But if you add a third node, yeah, it's like 2 to the power of 3, right? Here we only have 4, or no, it's 2 times 3. I don't know which math thing it is, but it's like this one combines with these two, this one combines with these two, and so on. So we get 2 times 3, right? And in the end, we'll get a lot of them, right? And puzzle input, I think, it's so small. The fuck? I was expecting it to be much bigger, but yeah, whatever. So the idea is, or I guess the question is, how many of these antinodes we are getting? And actually, it's not really how many of them, because some of them might overlap. So it's more of how many unique points are being affected by these antennas. So let's put on our tinfoil hats and let's try to save the city from the Easter Bunny. So how many unique locations within the bounds of the map? So we have to discard the guys that live in the suburbs, so we don't care about them. They can buy whatever. So let's see. So as usual, let's try to start with the hello world, right? So in OCaml, yeah, I have to use left. So in OCaml we have, this is the entry point basically. It's not really called the main, which is pretty weird, but it works. So we have, I wanted to see if it has like a quick start, but it doesn't. Okay, whatever. So we have print. Is it print new line? No, it's like printf. Print. Okay, OCaml print hello world. It's like a print function. Oh, nice. This is the side that I was trying to find. Okay, perfect. Print end line. Wait. Didn't I? Okay, so this one takes. Whatever. So this one takes a string and then it prints hello world, right? And it's gonna put. Oh, I don't know why I put an arrow there, but whatever. So I have a makefile that just runs OCaml and builds the thing, and right, we get hello world. Now, I was trying to find a way of reading the input easily. I couldn't find a function that just reads until you end the file. I don't know why languages are so stubborn to create that function. It's insane. So we have to write it ourselves, right? But OCaml should have OCaml read line. It should have. I'm not sure why the documentation is not the first thing. Yeah, there is a fucking dependency to read a line. That's what? Okay, let's see, because someone surely asked this question. So, like, no, I want to see a read line function. Okay, this one, right? Like, there should be a read line, input line. Perfect. That's the function that I wanted. So, what I want to do is basically have a buffer, right? I'm gonna use buffer, and we're gonna try to have a function that reads until end of file. So let's see if we can actually create this function, because first let's do the input reading and parsing, and then we do the solution, because every time that was the hardest one, and if it sucks I can just skip it and put, like, I mean, I'm also gonna put chapters for each part. Like, you can always just skip the input parsing if because the input parsing sucks. Okay, so let's have a function read input, and this one is just gonna be a function that gives us a string, simple, and it reads it from stdin. So let's see how we can do that. So I'm gonna have let buffer, so this is gonna be our string, is gonna be buffer create, and 1024 in, right? But I would like isn't there a stdlib read line? Okay, yeah. So this one reads a line, and it raises end of file. So how can we actually catch a read line? Because yeah, OCaml catch erase. Let's see, how can we do error handling? So for instance, I will fail. input. Oh, yeah, but I don't see where end of file is used. I guess it's here. So I guess I have to do like match read line, and read line, it says it's unit to string, so it's just a function that returns. So let's match read line with, and we have line, and in that case, actually, you know what I'm gonna do? Since OCaml has while loops, OCaml while. Don't even remember how you do while loop. While do done. Okay. While true do done. So right. Wait, do we have so OCaml while break? Can I have a break? Oh, you know what? I guess I can do, so in this example I can see it's try while done and then with. So I can do something like try while true. We are going to read line, right? Read line. And then at the end I can have with end of file. Oh, what with end of file, and if we get end of file, I have to generate the string from the buffer. So buffer contents, right? We get the contents of buffer. But now I have to use this read line. I guess it's like buffer dot append add buffer add string, and this one takes in buffer and wait. I guess let line is equal to that in line. Oh, I really have to write that. And I can put it in parentheses or something. Okay, I mean that works too, right? So I think this is how I read the input. And if I get end of file, I just will this work? Let's see. It almost worked, right? It didn't put the what do you call it, the new line. So what do I have to do is adding a new line here. Wait. I mean that works too, right? Okay, yeah, perfect. So that's how we get the lines. And now that we have the input, everything is good. Everything is easy from now on. So let's have a type. I guess yeah, first let's do input parsing and then we get to part one. So we have a type for our like antenna type. And do you write the types OCaml type? Do you write types with capital letter or lowercase? If I have a custom type, right? Okay, so lowercase. So we have an antenna, and this thing is gonna be, I guess I can have like this. It's gonna have an x coordinate int. Oh, you know what? How can I have a... I can have a tuple. I said this is like just a tuple, right? Int char. I don't need that. Okay, so it's just a tuple. I wanted to give them names. I think I have to use like the curly braces for the named stuff, but yeah, I guess so. I don't know if it's huh. I guess it's better if I would do, so it's x int y int, and I guess the freak one, let's call it freak, it's char. And maybe instead of x and y I'm gonna use row and column because x and y is too confusing for me. And you know, honestly, if you are feeling like when working with 2D arrays x and y is confusing, just use row and column and it's gonna be so much easier. Anyway, let's have now a function that takes in a string and it gives us the list of antennas. Right, so I would also like to have, you know, like in Haskell, like obviously OCaml, Haskell, all of them are inferring the types, so you don't have to write the types yourself. But OCaml define function with types explicitly. I don't know how to spell that, but Google will fix it for me. So okay, I can put, wait, I can do it like that. So this is parse input, is gonna take in a string and it's gonna give us antenna list, or right, huh, okay, let's do it in line. So I'm gonna have parse input, it's gonna get the input string and it is going to, oops, return an antenna list. Do we have undefined? Right, and it's gonna return a list of antennas. Right. Next thing, can I find here string.split on char? Nice. So string split on char, because that's gonna be needed for so new line. I don't know why I'm split on, it's because I programmed in stack so much. Okay, so this gives us a list of strings. Right, I'm gonna use let line is equal to, so this is I have to say string, not split on jar. Okay. So this gives us a list of strings. Okay, perfect. So why do I want the lines? Well, first line is first row, so we have already the row value, and now we just have to iterate each line to get the column value, right? So that's the main reason. All right, so how can we iterate these lines? Well, we have map, right? Or we don't have map. It's called array map. Array map. And array iter. What's nice about array iter is that it also gives us the index. So it's like the JavaScript map, right? So we have map, but this is just iter. Okay, we have map I, perfect. That's what I wanted, map I. So we have array.map I. Right, this one iterates with a function over an array, but this function also gets the index. So nice, we have the index. Okay, so here we'll need that function, and then we iterate it over the lines. And interestingly enough, this should be the output, but now we need that function. Okay, so should we just define it here? Let parse line is gonna take in the row as an integer, is gonna take in the line as a string, and it should output you know what, like, can I have flat map I? It should be like, oh, we don't have flatten. I mean, it is list flatten, but I mean, oh, it's not array, it's list map, but it's the same thing. Yeah, we have map I as well, and we have flatten, but we have flat map now. Anyway, I can do list.flatten at the end, right? I can do list.flatten, and that's fine. So here parse line is going to return antenna list, right? And this one is going to be something in, right? So you know what, like, this could just be another, like, a separate function, because wait, what? Okay, I closed that one. It was useful. Okay. Like this, yeah. Antenna list, and we have some stuff. Right, but Jesus, come on. Let me just get to the in thingy. Okay, perfect. So this one looks like it works, right? But we just need to implement this other function. So obviously we just need to map over each character. So I'm gonna do something like list.map_i, and here we need another function over the line, right? And this function is just the constructor for our type. So I mean, I'm just gonna do parse ch. It takes in the row, it takes in the column, and it takes in the ch char, and it returns antenna, row, column is column, and frequency is the character. What? OCaml data type. Right, the user defined ones. Yeah, like that, and then I just created, oh, so it's with equals. So it's like, right, and here I should have said that we return an antenna. And it wants, instead of comma, semicolons, right? Okay, so I guess that's fine. So I'm gonna do parse ch row, and that should yeah, exactly. So how do we convert, so camel string to list char, how we convert this thing? Oh really, there's no string yet. Where is the manual? String get. Okay, let me just close this. So list init. So that one just gets list init. Interesting. So yeah, it's pretty weird how you actually have to do it. This was the pipe. Yeah, I forgot about that. Yeah, that's a pretty cool feature from OCaml. I forgot about that one. So I can do something like explode. Right, we list init, take the line length, and we use this function, and then we can use the triangle operator, right? So this one is like the pipe thingy. So it generates the list of characters and it pipes it into this function. So you can use like it's like doing this in Haskell, right? But it's in a more obvious way, I would say. Or maybe that helps, right? So even here we can use that because it's much nicer. So we do that and then we flatten, right? And maybe even here we can avoid the let in, right? And we remove the lines, and then we can put it like this. So it looks more like Rust even. I mean, Rust was inspired a bit by OCaml, so we split the input by lines, then we map it with parse line, and then we flatten it. And I guess that's a good word to call this one, and then. Oh yeah. Anyway, so that's how we parse the input, right? So I could just say here that we read input, we parse input, and then can we print OCaml print custom data type? How can we print user-defined data type? Derive sexp? Oh my god. Oh my god, chill. Chill. Don't derive sexp on my... Yeah, I mean, that sucks, but... Well, it is what it is then. We cannot really print it, I guess. Or maybe there is a way. Like we could format or do something like that, but let's not do that. Okay, so let's try to solve part 1 now, right? That now that we have the input parsed, we can try to solve part 1. Right, so for part 1, let's have let part 1 function. This one will take the input, and again, actually it doesn't make sense to get just the input. We can just get the antennas directly, so the input is going to be just the antenna list, right? And honestly, string, and we output a string. Let's just do that. And was it number, right? Let's just do it like this. It's not think about it. Okay, so let's say it's gonna be like just 0, and then we'll have a solution function that takes in input string and returns string. And what this thing is gonna do, part 1, so we have string concat, right? String concat should take in, concatenates the list of strings, inserting the separate. String cat. I think cat, yeah. I was like, wait, I don't need that. String cat is gonna be, ooh, do we have show or int or camel show int to string or something? Int to string. How to convert int to string? It's just string to int. Nice. String of int. Wait. String of int. Interesting naming, I would say. Okay, so it's gonna be part 1. Actually, let's have let x is equal to parse input in. So axis is gonna be a list of antennas, right? So we'll do something like part 1 axis, and then we string of int, and then we concat it with part1, right? And can I have like a list of these things, like part2 axis string of int, and then string.cat part2, and then I can just say, because we just learned about string.concat, but why doesn't it like how I created this list? Because I don't have let part2. Okay, I didn't have part2 already. Okay, perfect. So what? Oh, and in OCaml you have to use semicolons for separating these things. So that's pretty weird, but whatever. I'm gonna do it like this. So we are gonna read input. We are gonna do solution, and then print endline. So if I run this thing now, I should see 0, 0. Nice. Okay, whatever. Okay, so let's try to solve part1 now. Actually, this time. Okay, so how do we actually solve part1? So we have to do the following steps. First step is sort the antennas by frequency. Right, I'm gonna call this one actually. So we have to sort the antennas by frequency. Then I want to group the antennas by frequency again. So here we are gonna get the antennas in order, right? Here we are gonna have something like, okay, all the antennas for A are at these coordinates, all the antennas for B are at these coordinates, and so on. Right, so we know the coordinates of each group. Then the third step would be to generate all combinations of 2 for each group. So as you saw here, if you add an extra antenna, it becomes more complex. So we are gonna have like first item with second one, first item with third one with 4, and so on for each group, right? For each of these groups. And that is gonna give us like each combination is gonna give us 2, how do they call them? Antinodes, 2 antinodes each, right? And then at the end we are gonna just flat map the entire thing and keep only the unique nodes. Okay, so it sounds not that complicated if you ask me. So let's see if we have a built-in sort function. List, oh fuck. Okay, I just clicked under things. Okay, so we have a sort function. And you know, the difference I would say between Haskell and OCaml is that here we don't really have like classes like a queue or stuff like that. It looks like all the functions just take in the sorting function. So you know, that's fine. I like the Haskell way of saying, okay, antenna is a queue, and then you just, like in Rust where you implement the trait. So here we have to define function that compare, so like antenna compare, right? We compare 2 antennas. So A1 antenna, A2 antenna, and it returns an integer. Jesus. So how do we compare these things? Do we have compare on chars? Nice, we have compare on chars. So can I say char.compare a1.frequency, a2.frequency? So that's how we are gonna compare two antennas. Nice. So as I said, first step is to do list sort antenna compare axis. All right, so that's the first step. It gives us the antenna. Now, the problem is we don't have a group function, right? We don't have a group. So we should implement it ourselves. Group. I guess I want a group by function. And we can make it generic. You know, it's part of those. So this group function is gonna take an A prime. Oh, no. Let group by is gonna be the like by function, or I guess fn, and this function is gonna be a prime boolean, right? Then we are gonna have it's prime a for like generic type, okay. And then we have prime a list, and it returns prime a list. Right. So that's how we are gonna do group by. So group by. I'm pretty sure we need a recursive function. So let how do we usually call these ones? Like go. And it should have like an accumulator. So can I search just OCaml group by group function? Maybe someone like at least something similar to group by, right? So it takes in a function in the list, and then we have to, okay, so rec is like this, right? And as I said, we need like a go function, like whatever, doesn't matter the name, and an accumulator, and you say is equal to function. Okay, and we have two options, but two options for what? Oh, at least we have partition, list partition. Partition returns a pair of lists, L1, L2, where L1 is the set of all elements of L that satisfy the predicate. Aha. So at least partition is something similar to what we need. Okay, yeah, you pass in L. So yeah, you can say that if so we'll have some stuff here, and then in, and in the in I can say go accumulator is going to be an empty list, and here I should put L or a name, so we can pass in L here. Right, so yeah, exactly, in case it's a L is an empty list, we just return the accumulator, and otherwise we'll have a head and a tail. So that's how you write head and tail in OCaml. Okay, perfect. Then here we partition, so we'll have to partition, we have to do something like this, but let me just do it like, but function. Oh, so this, wait, this is exactly my function. Yeah, this is exactly my function, lol. Yeah, and then we recursively call like this. Okay, yeah, I mean, it was a bit cheating, but so yeah, here it's good that we found partition at least. So this is like break in Haskell. So it takes in, so here you see we passed in head as the first argument. So now this entire thing just became a function that takes in one element and returns a boolean. And what this group by function is gonna do is just gonna be equals. So if head is equal to the first element, is gonna keep it, and so on until it's no longer equal, right? So this is gonna give us L1 is gonna be all the points that contain this one, like the first frequency, and the tail or L2 is gonna be the rest, but it's not compared yet. It's gonna be grouped after we call recursively to go, right? So we just put head and L1 into the accumulator, and then we call to L2. Okay, it makes sense. Yeah, it makes sense. I'm just gonna put everything in one line because I'm crazy. Okay. Anyway, so this is the group by function, right? But we need antenna grouping. Takes in one antenna, the second one, and I'm just gonna say, can we have char dot equal? It doesn't make sense. Char equal. Yo, there's no way there is a char equal function. So, as I said, we want to group our antennas by the frequency. So yeah, we are gonna get this kind of list. I would like to have it more like this in a way. Which it doesn't really matter. Yeah, it doesn't really matter that much. So yeah, whatever. Let's do group by, and we'll say antenna grouping, and that's just gonna give us list of antenna. All right, perfect. So what's the next step is to map over each one. So list.map will map over each antenna, and we'll get we'll need a function, right? As usual in functional programming, we always need a function. So okay, so we map. I saw this AoC function. Sorting OCaml generate combinations of list. There should be something in standard library. Combinations of two. I mean, I really think there should be a function for this. Anyway, let's do combinations. Right, and we are just gonna hard code this one. And by hard code, I mean, I'm gonna say we have a list A, and we just want to return A times A list. Right, so it's combinations 2. And here we have axis. And this thing returns whatever, I don't really care about it. So if I map combinations, I'm just gonna generate all the combinations of 2 antennas at a time. I think that's good. Combinations 2. So this is gonna give us list of lists of this thing. Combinations 2. And then I would like, I'm just gonna say here undefined, even though that's not a thing in OCaml, undefined. And then I would like a function that gives me anti-nodes. So this one is going to be a function that takes in a pair, or like, let's call it P for pair. And this pair is going to be just A, or maybe it's going to take in A1 and A2, and it's going to give us list. But this is already antenna, so, and the list is actually just gonna be points, right? So in the end we want to get only the points, so maybe we just reached the point of this, right? It gives us, wait, it's a list though, list of points that are generated by the antennas. Okay, makes sense so far. So that gives us the combinations. Should I just flatten the list of combinations? I think I should, right? So I generate a list of combinations. So this is going to be a list of pairs. So I can just flatten it. I can just flatten it. So now we have a list of pairs. A list of pairs. And I should be able... Can I have like a function OCaml lambda function? Can I have lambda function? The fuck is... like an inline function I want. How do I... OCaml it's annoying. Maybe I can just say this is a tuple and that's it. OCaml and curry. Oh, does it have curry? No. Okay, anyway, so it is what it is. Yeah, let's just say that you know, these are gonna be the antennas and it is just a pair. So then obviously we have to map anti-nodes and then we have to flatten again. And here I guess we can just say list.length for now, just to get some result. But we have to keep only the unique ones. And also what I forgot to add here is the bounds of the map. So we'll just add the bounds, but that's not really that big of a deal. We can just generate the bounds at some point. Anyway, so let's see, how do we make, I guess, the combinations and then antinodes? Or also, do we have a unique? Sort unique. Aha. Camel remove dups. I mean, this guy implemented it himself. I don't care about the ordering though. Is it gonna be called noob? No. I mean, this one, sure. And this is the exercises one. Oh my god. Ah, so it's just... Oh, this one is nice because we can just cheat by looking at these functions. The 99 exercises in OCaml, right? Yeah, whatever. Removing the duplicates is gonna be pretty easy compared to generating combinations. So how do we generate the combinations? Well, like, let's do a step by step. We take the head of the list, and we also have the head and tail. We have the head and the tail. So what we need to do is head, tail, first element, let's say like that, head and the tail the second element, and so on. And then we also combine this with combinations 2 of tail. Okay, so that's how I'm gonna do this one. So, but I also want to just have a recursive function. Go accumulator is equal to function some stuff in go. The accumulator is gonna be empty, and this thing is gonna be the list. So if we have an empty list, it's accumulator. If not, we have head and tail. And what I'm gonna do is basically I have to generate this entire crap with head, combining it with everything else and adding it to the accumulator. So in the end, it's just gonna be something like let cs is equal to something in go list.concat list.cat list.extend. How do I combine append L0, appends L1 to L0, so it adds it to the end. So I have to say, wait, again, append, same function as the infix operator. I'm gonna use append, you know what? So we do go append, and here I'm gonna append CS accumulator. I guess, and the recursive call is gonna be on tail. So how do we generate this thing then? I think it should be a list map. Then we have a function that we apply on tail. But okay, like OCaml list map lambda function. Like I want to have a lambda function in here. Oh, so I can, and I have to use fun. Function that takes in a t element, and what do we get is head and t. And obviously this, I call this one axis here. So this is combinations of 2, right? It's taking the head, it combines it with all the elements from tail, and then it appends it to the accumulator and recursively goes through the tail again. So yeah, I think that's how it goes. Now for the antinodes. Oh, I'm curious if we can actually just print this stuff. OCaml print list. Hey, how can I print a list? Damn, this is so annoying that you cannot just print. But I have a OCaml REPL open file. Like surely in the REPL I can. So I have to say use main.ml what? Also, it was just slow. But can I just define this one, for instance? And then say combinations, and then give it 1, 2, 3. The fuck? Whoops. But it doesn't look very good, I'll be honest. So it didn't work? Because I'm not sure what this output is. Like, it looks pretty weird, not gonna lie. Really, I cannot just say list.map function a x plus 1 and then give it 1, 2, 3. Oh, I know why. It's because I have to say 1, 2, 3. Yeah, it's with the... Okay, nice. So it works. 3, 4, 2, 3, 2, 4, 1. But they are in the reverse order. So I might want to do it like this, right? Well, not that it matters, but yeah, not exactly that I care about that, but 1, 2, 1, 3, 1, 4, and then 2, 3, 2, 4, and 3, 4, right? So it's kind of close. And oh yeah, I'm too lazy to do group by. But I'm curious why. So it was executing this stuff. So I have to remove it if I want to do use main.ml or what? It can be just this slow. Okay, I got it. It's because read input. Okay, so I have to make read input actually take in something. So it's like a lazy function, right? Nice, it makes sense now. Yeah, it makes sense. So use main.ml. It gives me all of these things. So I can say, for instance, that I want to, let's say, do part 1 or something, right? Or part 1. But I mean, it doesn't do anything yet, so but I can, for example, say like what, group by antenna grouping, and then have here like row is equal to 1, call is equal to 1, frequency is equal to A. Can I say something like this? I can. Nice. So then I can add another antenna. And finally, let's add another 1B. Alright, so it gives me B is one of them and A is the other one. Okay, so even group by is kind of annoying. I should do that in the reverse order as well, I think. Alright, it looks like it's they are reverted, but you know, doesn't really matter. So it's like what, accumulator, and then, but it's weird how it's reversed, right? It's really weird how it's reversed. No, actually it's not, yeah. So what I'm gonna do here is probably list append head and L1 was it? Wait, what the fuck? Yeah, but that's exactly like why I have to use append. Is because this is a the fuck? Wait, is this just adds it at the end. Oh, I want to do con, not cons. I mean, it's the plus plus operator from Haskell, right? This is just OCaml add at the end of a list to add an element to the end with the okay, yeah, fair enough. So it's like, oh, just do like this. I mean, yeah, it is what it is. Right, and if I try this one again, it should be like ordered. Nice. And what if I try to sort these ones? So sort was list sort antenna compare. It should be the same thing because it's sorted. Yeah, already sorted. So stuff works. We just need to implement the antinodes thingy and let's say so parse input. let's change parse input to also give us the I'm gonna say probably let axis is equal to this stuff. Damn, this sucks. So I actually have to use lines and whatnot. Lines in let height is equal to list dot length line. So this is the height. Width is equal to, do I have end or something like that? List end, yeah. Width is gonna be list dot end, and we need first line and string dot length. So that's the width, right? And then we just need to say I guess it's easier to just lines and then flatten it. So this is the antennas, and I can write width. So that's how we actually parse the input. We get the antennas, the height, and the width. Parse input. Can I match? No. No, it's gonna be width, height. Right? And width, height. This guy should get the width and the height. Right, so part 1 also takes in width and height. I think I just put them width, height, and here I need to say width, height. Let's not that's why it's better to use data types than tuples, right? Because you actually give them names, but this is fine. So here we also get the width and the height, because after flattening we need to have let bounded. It's gonna take in like xy, or I guess pair, int, let's just call it pair, and then with height, and it's gonna return a true. Right, and here after flattening, list filter bounded, and then we get the length. Oh, and actually bounded should be maybe like this, so we can say here with height, and I'm just gonna put it in parentheses. Right, so let's try to do anti-nodes, because that's the more interesting one. Okay, so can I have directly here A1, A2? I can. That's cool. Nice. So what I'm gonna do is have xdiff is gonna be a1 dot, or you know what, it's gonna be column delta a1 column minus a2 column in row delta a1 row minus a2 row in, and here I'm gonna put undefined. So we are gonna get the delta for row and column, right? I think I want the absolute value. Let's think. Do I care if it's the absolute value or no? It's not even that important. Maybe it is though. So to get one side I have to do minus minus, and to do the other side I have to do plus plus. Okay, I don't think it matters. So I'm gonna do something like a1 dot column minus column delta. So if we look at the puzzle input, this is gonna be like go on the column to the left, right? But if this is negative, it's gonna go to the right, right? So it also gives us the sign, so it's gonna work regardless of the sign. And a1 dot row minus row delta, and then we need the same thing for a2, but here is gonna be plus a2, but here is gonna be plus. So this is gonna be the antinodes, right? On one side we subtract the columns and like the deltas, and on the other side we add the deltas. That's how I think it's gonna be. So if this guy was here, if I do minus minus, wait, is this how it works though? So if I have like antinodes, let's say position 1 1 and position 2 2, I have to get 0 0 and 3 3, right? So let's say the delta is gonna be minus 1 minus 1, so I guess I have to do plus in this case, right? Or do I? Let's think about it. So if I have positions 1 1 and positions 2 2, I'm gonna get delta to be minus 1 minus 1, because you know 1 minus 2, right? And I look at the first antenna, which is 1 1, and I add the delta there, so we are gonna get 0 0. And then for 2 2 we are gonna subtract it, so we are gonna get 3 3. That sounds good. But what if we have 2 2 1 1? Like what if they are in the other order, in the reverse order? The delta is gonna be 1, so if we add 1 it's gonna be, yeah, I think it's fine. And what if we have 1 2 and 2 1? 1 2 is gonna be minus 1 and 1, so it's, I would have to draw this one because I cannot think that well with. So if we have, let's say this is the grid, right? And we have, let's say this is 1. Let's say we talked about like these are the columns and these are the rows. So we have column 1, so this one, and the row 2. 0, 1, 2. So it's here. And the other one is at 2, 1. So 2, 1. So we need one here and one here, right? Yeah. So this is at 1, 2. And the other one is at 2, 1. So the delta is going to be minus 1, 1. So here, for the first one, we add 1 here. So it's going to become 2, 3. So 0, 1, 2, 3. 0, 1, 2. And then 0, 1, 2, 3. So it would be here. But why is it here then? And the second one would be with minus. Oh, I said plus, I'm retarded. So if I do plus, it's 0, 3. So it's 0, 3, which is good. And for the other one, we do minus. So it's gonna be 3, 0. Yeah, it's fine. I think we are good with this approach. I think we are good. So this is gonna give us the antinodes. We are gonna filter them by bounded, right? And what does that mean? What does it mean for them to be bounded? Well, we want, let's say, so I have column row. Let's have that column row. That's how we store them. You can see here column row. So width is for the columns and height is for the rows. So we want the following: 0 to be less than or equal to column, and column to be less than width, and also the same for row and the same for row with the height. Okay, so it doesn't, it's like and. Okay, whatever. So that's bounded. So that's gonna give us the bounded ones, but this also contains duplicates. This also contains duplicates. Let's see. Let's see what's gonna happen if we make and we just pass this. Okay, let me just create a temporary file with just this input. So the important question. Oh my god. The important question. Is that we did an oopsie doopsie. Obviously for parse input, I also want something else. I also want, do we have trim, string trim, because it's annoying. So when we parse input, we want to trim it. Right, we want to trim it, but that's not but why is it such a big number? Why is it such a big number? I think I just let test input string, and let's say, you know what, let's let's say it's gonna give us antenna list. And what do I want to do? Is parse input. So this is gonna give us, wait, let's say I also want the width and height. So I'm just gonna comment this one out. And let's do OCaml. Oh my god, use main.ml. Really? The fuck? Okay, so we got some stuff. If I say read input, and I pass it nothing, and then I just copy paste, we get something like that. So what if I do test? Oh, I forgot about the dots. Okay, so what does that mean in parse ch? So here we map iParseLine, flatten, and then we have to filter out the dots, basically. That's what I forgot to do, maybe. List.filter. Let antenna empty takes in an antenna and returns a boolean. So a.frequency is equal char equal a.frequency dot filter. But can I say compose? Can I compose two functions? The fuck, who asked about F sharp? Is this guy smoking something? Okay, so it doesn't work. So antenna non-empty. I'm gonna say not. Actually, let's pass that into not. use main.ml. I really need to install, there is that tool that lets you do like a wrap around the weird terminal. Okay, nice. So now we get just the correct ones. We parse just the correct ones. Perfect. You know what I'm talking about. Read NixOS. Is it in Nix? I don't know. Well, I'll see, but would have been nice if I had it before. Anyway, so let's add more stuff to our thing. So now we just tested that. Let's try to test flattening this stuff. So here I'm gonna let, oh, I deleted the axis with height is equal to in. So here we just not input equals. And then really how we read, and we try to put these guys in. So this gives us all the combinations, right? 1-8 with 2-5, 1-8 with 3-7, 1-8 with 4-4, then 2-5 with 3-7, 2-5 with 4-4, that looks good, and 3-7 with 4-4, and then we have only 3 combinations for A, like A from 5-6, so I guess this one, with A from 8-8, 5-6 with 9-9, and 8-8 with 9-9. So it's only 3 combinations for those, right? It's like this one with this one, this one with this one, and this one with this one. Yeah, nice. So that's there. Then we generate anti-nodes and flatten. So let's see the anti-nodes as well. Let me just copy this. Did I copy that shit again like that? That's crazy. So these are the anti-nodes, right? And the last thing is to just filter the unbounded ones. So let's see if it's gonna work now. I think that's what my mistake was, right? 15. So it's an extra one. Why is there an extra one? An antinode overlaps, so we need to remove the duplicates as well. So after we filter the bounded ones, we have to remove dupes. And you know what? Let's just let's just copy this thing and let's see what it's about. So we have unique cons. So this thing is something like a list of A. No, this is just an element. Just an element, and this is a list, and this thing returns boolean. So if X is a member, then we return X. Oh, this thing returns a list. So if X is a member of the list, then we don't include it, otherwise we include it. Yeah, so it's like n squared complexity, but that's the only way to do it, right? In this kind of languages. And it also returns just a list. So it's using fold. Fold. Oh, fold 2. Okay, anyway, fold right. It's curious that it doesn't have. Oh, it does have the accumulator. Yeah. Okay, makes sense. So this is basically the element. This is the accumulator. Let me just say, but no. How does this work though? Because it's a function that takes in. Yeah, I mean, yeah, this is the accumulator, yeah. So if x is in the accumulator, we don't. Okay. Yeah, makes sense. So I would just have to do this, right? Remove from right. So now if we run this thing, we should see that it's only 14. So if we run it on our input, we get 398. Will this be the answer? And it was the answer, so easy. I mean, yeah, it took a lot longer than expected, but that's because functional programming. I'd say why it took longer is because we didn't have checking for uniques, we didn't have generating combinations, we didn't have group by. We lost a lot of time on parsing the input, as usual with any language that I try. It always, like, it just became the norm now to waste time with input parsing. But yeah, that's, I'd say the more, like, the more affecting ones were combinations and like getting used to writing them like this, because it's like Haskell, but it's a bit different. So yeah, that was part 1. Let's see what part 2 is about. Let's see. Watching over your shoulder as you work, one of the historians asked if you took the effects of okay, okay. After update. Oh no. Okay, I see what's this one. So let's see. It turns out that an antinode occurs at any grid position exactly in line with at least 2 antennas on the same. So I have to generate, it's like hops, right? It hops. So these are 3 see, it hops, like this is the original one, but now we have to do the hops as well. Oh yeah, that fucking sucks. Okay, shouldn't be more annoying than the first part, because now when we generate the antinodes, we just have to do more, right? We just have to do more of them. But how is that gonna work easily? How is that gonna work easily? I was just thinking I could move this one. So does OCaml infinite lists. Can we have like a lazy infinite now? Oh, we can. Then should be nice. So what I'm gonna change for part 1 is actually I want to filter this list here. Right. So we are gonna filter it right here. And this thing is also gonna take in, the antinodes is gonna take in width int and height int. Right, it's gonna take them as variables. So antinodes is gonna be width height. Right, and I'm expecting to see the same same result. 398. Why did I want to do this? Well, we are just gonna define antinodes 2. So for the second part, we are gonna have antinodes 2, and this one will actually generate them let's see, what did this guy said? Harmonic, resonant, and I'm gonna say this is a function. So resonant 1 is gonna take in antenna and like call delta int and row delta int, and maybe it's just resonant, and it takes all of these and it returns int. But what if I wanted to return an infinite list? And in here it's actually going to be easier to just have a tuple. So like column a row, and it's going to be int, and for the deltas as well, it's going to be easier. All right. And here I'm going to say we filter resonant A1 column, A1 row. So that's the first argument. And the delta is going to be call delta row delta. Right, and then we have can I maybe do oops release.concat just to get rid. So we have that, but here it's A2 and here it's minus for the deltas. So now how can we implement this one? So I want it to like, is filter gonna work on an infinite list? I don't think so. So we have to figure out another way. We need to take while or something. Take while. Do we have take? We have take while. What is a sequence? Ah, interesting. So I have list to sequence. What if I return then a sequence T? What if we do like a sequence or something like that? Right, and here we should do something like sequence that take while the predicate is true. So while bounded with height, right? Bounded is gonna be basically that, and here we need to say something like this. So this is gonna give us a sequence. How can we convert then a sequence? List of sequence. List of sequence. Let's just say list of sequence. Right, so we do actually, oops, something like this, and then we can maybe list concat. Maybe this is gonna work. So now resonant. I have to see, so sequence append. Sequence append. So I just have to do the plus basically at this point. I just have to do, oops, I just have to do this plus and have like column plus column delta, row plus row delta, and add it to the sequence. All right, so it's gonna be something like this. Sequence dot cons takes one element and one sequence. So then we might be able to just say resonant column row col delta row delta. Should this work? Ah, I have to say this one is recursive. Is this going to work? Because basically this just generates a sequence. So this, if we say take while, it should stop. But I don't know if this language is lazy. If it's not lazy, then I mean, we are just gonna put this condition in here as a base case, so that's also good. Like, it shouldn't matter that much. So here we just say antinodes 2 for part 2. Let's see for, yeah, is OCaml lazy? No. Okay, so it won't work. Well, we tried. So then resonant, how is it gonna work? It also needs width and height. It also needs the width and the height. Width, height. Right. So we are gonna take this guy and we're gonna say let point in. Right. And then we are gonna say if bounded with height point, then we are gonna do basically this part, ca point, else we return sequence empty. So then with height, yeah, I thought it's gonna be like a lazy language, so if it was lazy then this would have been cooler because, oh, infinite lists like in Haskell, but I guess it's not. And something's broken still because I'm stupid. Here I should send the point. So we go next. Oh, maybe that was the problem with the first one. Oh, but why do we get only 14? Why do we only get 14? Shit. Yeah, maybe that was the problem with the infinite list. Let me see. If we go back, and I say here point, I have to say this thing. No, it wasn't that. Okay, so it wasn't that the problem. But why doesn't it work? So if bounded, then we go again. Otherwise, we just say it's empty. Oh, because here I said I forgot to say A1 and minus. I just copied it. 29. It's closer though, but it should be 34. It should be 34. Including the antinodes that appear on every antenna. Ah, so it also adds the number of antennas. I guess it makes sense. So I have to say something like, can I say into axis, no, list.length axis plus, or like int add. Right, we also have to add the number of antennas, 36. Let's add the antennas here actually. So we generate antennas. Should I just add them here? Shouldn't just I add them here? Like, so this is a list of lists. So I have to say like a1 dot column, a1 dot row, and a2 dot column, a2 dot row. So that that should do it actually. 34. Almost lit. Let's see. We are one step closer to finding the chief. So that was the thing, the trick, just adding the antennas themselves. Because if you think about it, the antennas themselves are also gonna be points in the second part. But yeah, it's nice how we just had to change the way we compute these points, and it was a pretty neat problem. Like I can see some nicer points about OCaml when compared to Haskell, because you know you actually have while loops and stuff like that. But as when it comes to the actual functions, I think Haskell has more functions like that are useful. So yeah, maybe you can just use dependencies, but I want to go like no dependencies only for each day, just to get a feeling of like the plain language, how it feels, right? And I mean, I don't remember if I ever tried OCaml, to be honest, but you know, I've seen a lot of OCaml stuff, so I kind of knew some things about it. But I would say it's pretty nice. It's like it's a Rust-like, I would say. I mean, you know, inspiration for Rust, but it's pretty. I'd say it was a pretty fun day to try something like this language. So yeah, pretty nice result. So I would say that's all for today. Maybe one small thing I added to the repo, which I can show at the end now that you know, it's pretty neat, is I want to make like this page for each day, and each day will have its own step-by-step simulation for the solution, right? I mean, the only problem is I have to do it in JavaScript, because that's how the website you know, the front end is in JavaScript, and I don't, it would suck. Imagine like I could use WebAssembly, but that means learning how to do WebAssembly in each language that I use. And yeah, so far I only did the first 2 days, so, but it's like step by step on how the solution works, like what the algorithm that finds the answer, which I think it's pretty neat, right? And you can also just have an automatic solve. Let me just speed it up a bit, like 20 times, so you can see how it goes through each step by step, which is pretty nice. Like if you want to understand how the algorithms work for these Advent of Code days, you can just step by step go through the problem, and you can even paste in your own input, but you know, just use this one because it's smaller and it takes a lot of time to just click through each step. So yeah, I mean, it's pretty cool. I'm gonna try to make it for every day, and yeah, hopefully it's gonna be done at some point, and we can make like I'll make an update and showcase it then. So yeah, I'd say that's all for today then. Day 8 in OCaml. So let's see tomorrow.